Hey everyone, welcome to the 6.4 and 6.5 review. I'm going to do everything on the left side, and then I want you to do everything on the right side. Alright, so let's get started. We're going to solve this equation. We have a cube root on one side, which means to get rid of it, we have to cube both sides. So, negative 4 to the third power is going to be 64, negative 64. And then on the left, you just have 5x plus 1. The cube root goes away, okay? So now we just need to solve for x. So I can minus 1 over, that gives me negative 65. And then I have 5x equals that. So if I divide by 5, negative 65 divided by 5 is going to be 13, negative 13. And that's the final answer. Alright, so let's move on to 2a. Here we're going to solve this. It's set equal to 0, so first step is to add this second term to the other side. So I'll just do that. And so I'll have the square root of 2x plus 2 equals 3 times the square root of x plus 1. Alright, so basically we need to get rid of this square. So you have to square both sides, even that 3 that's on the outside of the square root. Okay, so what that's going to do is that's just going to give you 2x plus 2 here, but you're going to square 3, and so that's going to become 9, and then it's going to be 9 times x plus 1. Alright, so you should distribute that 9, and that gives you 9x plus 9 equals 2x plus 2. And now everything is solvable at this point, so cancel one thing out on each side, so I can like minus 2 to this side, cancel one thing on the left, cancel one thing on the right, so I'll minus 9x here, minus 9x there. I'm left with negative 7x equals 7. So if you divide by negative 7, well, x is going to equal negative 1. Alright. So yeah, the key there on that one was normally when you square both sides, you're just left with what's inside the radical. But if there's something on the outside of the radical, don't forget to square that as well. That's why the 3 became a 9. Alright, so I am going to solve this one. And what I'm going to do right now is I need to call an audible. There's a bit of a typo here. That's going to become a minus, and this is just going to become an x, because otherwise it's not going to be able to factor, and then we can't really solve it by hand. It'd all be graphing calculator stuff at that point. So the first thing I'm going to do is I'm going to add x to the other side. Alright, and I'm going to change the 6x minus 8 to the 1/2 to the square root of 6x minus 8. They're the same thing. I feel like it's easier to understand if you write it as a square root. So it's going to equal x now, and then just like last problem, I'm going to get rid of a square root by squaring both sides. So that's going to leave me with 6x minus 8 equals x squared. Okay. So I just rewrote it right now. So what I'm going to do is get everything to one side. So I'll minus 6x and I'll add 8 over to the other side with x squared. And so that's going to give me x squared minus 6x plus 8 equals 0. So what are my factors of 8 that add to negative 6? And that's negative 4 and negative 2. They multiply to get 8, and they add to get negative 6. So I'm going to say x minus 4, x minus 2 equals 0. Okay, so I get x equals 4, and and x equals 2. All right, at this point you should check for any extraneous solutions. And so when I got x to the other side, if I just plug in 4, that equals 4, and if I plug in 2, that equals 2. It equals positive numbers. And then you can just do a check here. What's 6 times 4? That's 24 minus 8. That's 16. The square root of 16 equals 4. That works out. What's 6 times 2? That's 12. 12 minus 8 is 4. What's the square root of 4? That's 2. So it equals a positive 2. That works out. So there's no extraneous solutions here. So basically, we're done with this. You can just circle both of them and move on. So for A, you have an inequality. So with the inequality, you should solve it like normal. Always start with adding or subtracting first. And I'll minus 3 to the other side. And that's going to give me positive 20. And then I have 4 times the square root of x. So now I'll divide by 4, and that'll give me a 5 on the other side. So the square root of x is less than or equal to 5. So what you need to do is square root both sides, and you get x is less than or equal to 25. Now because this is an inequality, and it says it's less than, you're not quite done yet, because what's less than 25? 24, 23, 22, 21, and so on. But then it's also negative numbers are less than 25 as well. And this was a square root problem, and you can't square root a negative. So remember, you have to take whatever's inside the original square root, and you have to set it to be greater than, and in this case it's going to be greater than or equals to 0. It's greater than or equals to in this case because the original was or equals to. And so if there was stuff to do, if this said like x plus 1 is greater than or equal to 0, you'd have to like minus 1 to the other side. But this just says square root of x. So by writing x is greater than or equal to 0, you're done. You just need to write the final answer. If you were to flip it, it would look like that. Okay? And then x is still less than 25. So this is the proper way of writing it, saying that x is, in between 0 and 25 to make this true. Okay? So for 5a, you see you have a greater than symbol. So I'm not really going to have to do that extra work, because no matter what, greater than, every number I plug in, it'll just get bigger, not get smaller like with negative numbers. So I'm just gonna solve this once. I'm just gonna square both sides, and I'll get x plus 10 is greater than or equal to 36 minus 10, and you get 26. And so you see, I don't have to worry anything about negative numbers. Even if this 26 was negative, because it's greater than, like I said, it'll just keep getting bigger the larger the number you plug in, so it's not going to make any solutions go negative. So you only have to do that for the less than or equals to inequality problems. For 6a, here's a less than problem, but you'll see here that it's a cube root. You can cube root a negative number. You can't cube root, or you can't square root a negative number. So this is also going to only have one answer because it's a cube root. You can type in the cube root of negative 64, and that's negative 4, just like what we did here. Oh wait, never mind. I cubed negative 4, but I think you get what I'm saying. So what I'm going to do is I'm going to cube both sides, and that's going to give me 2 over 3x plus 1 is less than or equal to 6 to the third power is 216. Alright, so I'm going to minus 1. That's going to give me 215. And then remember, the way to get rid of a fraction is to flip it and multiply. Alright, so I have to do 215 times 3 over 2. And I'll get 322.5. And like I said, I know it's less than, and so that would encompass negative numbers, but you can take the cube root of negative numbers. We covered this in the 6.4 notes, so if you want to see some more examples, just check out those videos, okay? But that's done for 6a. Now moving on to number 7, we have x squared minus 9 and x minus 3 as our two functions. Here I'm going to divide the functions because it says f over g. So I'm just going to write x squared minus 9 over x minus 3. Alright, so we're dividing two functions. It's easier to do when, let's just factor x squared minus 9. We've been doing this all year long. That's a difference of squares. A difference of two squares, I should say. So remember, the pattern for a difference of two squares is that it's going to be, take the square root of each term. So x plus 3 and x minus 3 is the pattern. Alright? And the reason why I point this out is that the x minus 3's are going to cancel. And so you have just x plus 3 as your f over g of x function. Alright? Remember, this goes back to several weeks ago, where if you had something on the bottom of the fraction, what can x not equal? And I can't plug in a 3 because I'll be dividing by 0. So you'll just want to say that here. And then, yeah, let's just move on to the next one, okay? Here I'm just plugging in negative 3. You're plugging in negative 3 into x plus 3. So what's negative 3 plus 3? That's 0. That's all that one was. Okay. So what's the domain? Again, just graph the answer. Graph x plus 3. And we're going to look at the domain and the range. Only it won't show up in the graph, but remember x can equal 3. So let me pull up the graph of x plus 3 real quick. Okay, so here's a snapshot of the x plus 3 graph. All linear functions have a domain and range of all real numbers. You can see it moving left and right freely and up and down freely. Oops, sorry about that. But here I'm going to try and, there, I pasted it over this, but watch. It just disappears again. I don't know, that's weird. So we had the domain of all real numbers. But remember, we said earlier that x could not equal 3 because of that x minus 3 on the bottom of the fraction. So if x can't equal 3, surely that will affect the range. So let's go look at where x is 3. So go 3 across, and that's 6 up. So we have a little discontinuity here at 3 comma 6. Alright, so if x can't equal 3, then y can't equal 6. So for my range, that's what I'll say. The range is all real numbers, except for the number 6. Okay? And that's it for 7 through 10. So for this next one, we're going to do several function types we're going to add. Then we're going to multiply, we're going to subtract, we're going to divide. So I'm going to do all that stuff first. So, see here. Let's put it all in order. Negative x to the third minus 2x squared plus 6x. And then the other one's in order, x squared minus 5x. So here I'm going to add the two together. So that one's pretty simple, just add like terms, and I'm going to plus it to x squared minus 5x. So I don't have any sort of x to the third term, so it's going to stay negative x to the third. I have negative 2x squared and plus x squared, so that'll be negative x squared. Oh, and I wrote x squared by accident. This one's to the third. Then I have 6x minus 5x. That's just going to be x. So this is my f plus g of x function. Alright. The next thing I'm going to do is do the f minus g. So same thing, just write negative x to the third minus 2x squared plus 6x plus x squared minus 5x. Combine like terms here. Oh wait, why did I write plus? We're clearly subtracting, so my bad there. So don't forget to distribute that negative. So I have negative x to the third, and then I have negative 2x squared minus x squared, so that becomes negative 3x squared. And then I have 6x minus a negative 5x, so that becomes plus. So 6 plus 5 is 11. So there's my f minus g function. Alright, so let's do the multiply one next. I have it set up, and you're just going to have to distribute. So you're going to have to do negative x to the third times x squared. Remember, you would add your exponents together. And then negative x to the third minus 5x is going to be, times a negative 5x, will be positive 5x to the fourth. Yeah, because to the third times an x, it would go up in power by 1. And then you're going to do negative 2x squared times x squared, and that's going to be negative 2x to the fourth. And then negative 2x squared times negative 5x will become a positive 10x to the third. And then lastly, I have to do 6x times x squared, so that'll become 6x to the third. And then 6x times negative 5x will become negative 30x squared. And are there any like terms you can add together, or combine together, I should say? And so we have 5x to the fourth minus 2x to the fourth. So we have negative x to the fifth plus 3x to the fourth. And then these two are like terms, so that becomes 16x to the third minus 30x squared. And this is my f times g. F times g. What am I saying? Yeah, f times g. Of course I said that right. I don't make mistakes. That's my f times g function, everything right there. Kind of a mess, but I think you get the picture. Now let's do f divided by g. So here I have it set up, negative x to the third minus 2x squared plus 6x all over x squared minus 5x. The only way you can simplify this is by factoring. These all have a common x. And since this is negative, if your front term is negative, always factor that out. These both have an x, so you can factor out a positive x. So it's going to look like this. Factored out a negative x, so that became x squared plus 2x minus 6 now. And then I factored out an x, so it's just x times x minus 5. This can't factor. There are no factors of negative 6 that would add up to positive 2, because 6 is 3 times 2. Make one of them negative, it's still not going to add up to 2. And then 6 is also 6 times 1. Same thing, they'll never add to a positive 2. So the only way this can simplify is by canceling out those x's. And so you just have negative, and then you can just write x squared plus 2x minus 6 over x minus 5. Remember, x can't equal 0 because of that. And then x can't equal 5 because of, well, that. Okay, So yeah, we've done all the dividing stuff. Now let's just plug in. All we have to do is plug in -1 into our +1, plug in 1 into our -1, and then that's all the ones you have to plug in. So I'm going to do that off camera. So plugging in -1 into the f plus g got me a -3. Plugging in +1 into the f minus g got me +7. That's all there is to that. The next thing we need to do is identify the domain and range of your f times g function. So what we're going to do is we're going to graph it. So here it is graphed. You kind of have to zoom out quite a bit as far as the height of it. You see it goes up to 500. But you can see that it's not restricted in any sort of way. Just because it's wavy doesn't mean it can't equal something. So it's all real numbers is what I'm trying to get at. It's all real numbers for domain and range. Okay? So you can just say D and R are all real numbers. Alright? Now as for number 18 and 20, let's see here. We had this as our function to graph, and we already know that x can't equal 0 and 5, so we got to look at those spots on the graph. Okay, so here's a snapshot of the graph. You can see the domain is moving left and right freely except for the two areas that we talked about previously. So the domain would be all real numbers where x can't equal 0 and 5. The range, you just need to look at the spots where x can't equal, and so I pulled up the table. And so 5 was already undefined because it was underneath the answer. But because 0 canceled out, you can't equal -1.2 as well. So the range is going to be all real numbers where y can't equal -1.2. And as far as the other answer that y can't equal, it's kind of weird. What I did was I went to wolframalpha.com and I typed it in, and it told me that y can't equal these two values. So we'll just leave it there. Don't worry about a problem like this being on the test. But yeah, that's that's what it'll be. So sorry for the weird problem to wrap this up with, but hey, I don't know. It is what it is. Thanks for watching, especially if you watched this whole way through. This is probably one of my longest videos. Good luck on the test. Bye.